Hi. So I've been seeing on Discord a lot of questions about how to approach studying for the exam, and I've also been receiving some similar questions via email, etc. So I thought I would put together a little video on effective ways to study for physics with a particular emphasis on the structure of our particular course. So let's go through this. The thing to keep in mind is the structure of the course and the whole point of physics as a discipline, because that's going to inform how you study for the exam. So remembering that in this course, the book provides the basic information that you need to understand what we do in class. The homework then gives you a chance to check that understanding, which we then follow up with a quiz to make sure that everyone's on the same page. Then in class, we do a bunch of practice problems that allow you to practice the material and discover some weird corners and particular insights. And then what we're here to talk about, the exam, which requires you to use the skills and knowledge developed over this entire process to learn things about new situations you haven't seen before. And this is because of the structure of physics as a science. The goal of physics is to uncover the fundamental concepts and rules that govern everything, right? And we want to express those concepts mathematically, this new language of mathematics that we've been talking about, and then apply these rules to learn new things or new insights about how the world works. So that's what physics is about and how it's reflected into this structure. So how does that inform how you might best study for this exam? So let's think this through. Well, the exam is going to check your ability to do new problems using the skills and tools we've been practicing in class, right? It's going to be new problems. So to study, how do you do that? Well, think about the flow of the course. You need to make sure that you understand the fundamental concepts that underpin all the problems we've been doing. And this is where the book and the homework come in, or the energy story we've been practicing in class, right? So if you're feeling a little shaky, maybe going back to the book or the homework to brush up on those concepts is a good idea. The next thing you need to be able to do is make sure that you can translate these conceptual ideas into our mathematical language and vice versa. This is something we've been doing in class, usually the first day or so of each unit. So that's a place to look if you're struggling with that particular aspect. And then the third part is the exam is going to be, as I've said a few times now, new problems, right? So how do you practice and study for a problem you haven't seen before? Well, think about playing an instrument. How do you learn to play piano? You play piano. You don't watch someone else play piano, right? You don't practice on a guitar, although that will give you some transferable skills. The way to learn to play piano is to play piano. So the way to learn to apply these skills to new problems is to do new problems. And that's what we've been doing in class, but I'm expecting that many of you, if not most, will probably need a little bit more practice. So that's the general overview of the best way to study for this exam. Let's now get a little bit more into the particulars. So for the first part, this mastering the concepts, the best tool here is something you might not have thought of. Right. This is actually how I study for exams. I was very privileged to have a very good high school physics teacher who was actually pursuing a degree in physics education research. And she taught me this, and I have never left this particular strategy. And obviously it worked for me. You know, maybe it won't work for everybody, but I think it's pretty effective. So the basic idea is to make an outline of the material. Now, this might seem kind of daunting. It seems like there's a lot of material there. But when you go and do it, you actually might be surprised about how little information there actually is in each unit. So here's the skeleton of an outline for our first unit on entropy, right? So it starts with entropy because that's the big topic of the first unit. And then entropy is, and then you've got the two main terms about entropy, microstates and macrostates. And then The quantity on which entropy depends can be determined, right? You've got the binary, the non-binary case. You might need to define these words. Then you've got that mathematical representation that we talked about earlier in this video. And then if we want to determine probability, how would we do it? What happens as the number of molecules goes up? The second law of thermodynamics. And that's genuinely it. That's all the content for the first unit. Now, granted, the first unit is probably the simplest, which is part of the reason we started with it, but that's really it. Now, I can hear what some of you might be thinking almost, and it's, why don't I just give you these outlines? Because reading them doesn't work. And a good example is all this information is already in the book. But if you're not recalling and being able to fill these blanks right out of the gate, well, that's indicative of the fact that reading somebody else's outline is not actually effective. You have to actually do it and synthesize it and put it into your own words. Now, one benefit is that if you create something like this, you can upload it as one of your metacognitive journal entries. And this will be an essay, so it would count for 2. And if it's really good, heck, I might put it in the book, right? So this is a good exercise, and I would highly recommend doing it to study for the exam. And you can also maybe get some benefit towards your metacognitive journal assignment. So then the next step is in this, what really is physics? The first part is got to get the concepts. The second part is sort of this translation to mathematics. So what are good ways to study that particular step? Well, first, you got to know your symbols. And here is a list of all the symbols we're going to use. The little question mark in the U is there's 3 of them. You should probably think about that, right? So that's all the symbols. So you need to understand what all these symbols mean. These are the vocabulary of our mathematical language. These are the words that we're using. So if we're thinking about math as a language and this is our vocabulary, well, most of you, I think, have probably studied a language before. How did you study the vocabulary when you were studying Spanish or French or Latin or German or Chinese or Arabic or whatever it was, right? How did you do it? Well, what most people do, I know what I did when I was studying Latin, was you make a flashcard. And you can do the same thing here for physics. It actually works great. And it's something that, frankly, a lot of people don't think of. So you can make flashcards for physics. So on one side might be one of these symbols, say W, and then on the reverse would be what that letter can represent. And I chose W for this example because it can be 2 things. It has 2 different meanings, the number of microstates, if we're talking about entropy, or if we're thinking in terms of energy, W is the work. So it has 2 different meanings depending upon context, just like how the word buffalo can refer to the big lumbering bison animal, the city in upstate New York, or it can mean to bully, right? It has multiple definitions. So some of our symbols also have multiple definitions. Also, be careful between your upper and lowercase. Lowercase k and uppercase k are different. So make sure that you are paying attention to that when you're doing your flashcards. Also, you might want to throw in some of your symbols, like this angle bracket thing, right? You should know what that symbol means. Or the delta is always the final minus the initial of some quantity. So delta x is x final minus x initial, right? The equal sign, that's usually your verb. Make sure you understand all those symbols and how they differ. How is the equal sign different from this fish-shaped proportionality symbol? So that's a good technique for that particular skill. So now we've talked about how maybe to master the fundamental concepts, how to approach understanding the math as language, develop this fluency with our mathematical language. And now we're to the third part, the doing new problems. Now I can guess that some folks are going to want to jump to here. I would actually not recommend that. I would recommend doing these in the order that we've talked about them. Make sure you've got your concepts down first, and then make sure you're fluent with our mathematical language next, right? Because the mathematical language builds on the concepts. And only then going and trying to do the problems. Yes, that's what I'm going to test you on for the most part. There are some more direct, can you translate mathematics? That is on there. But if you don't have step 1 and step 2 mastered, step 3 is not going to be as successful. So make sure you try those other 2 things first. So when it comes to doing new problems, you've got 3 main resources. You've got the next time problems, which have this little post-it note icon, and they're in the slides at the end of most days' classes. Not all, but most. And these are, I think, your first place to look, because they have you. If you get stuck, you know where to look. The next time problem for a given day is a riff or a slight adjustment or a slight next step from the problems we did in class that day. So if, say, on Wednesday's class, you're looking at that next time problem and you don't know how to do it, well, look back at the problems we did on Wednesday and see if you can tease it out. Moreover, these problems have full solutions at the start of the next day's slides. So Monday's next time problem has a full worked out solution at the beginning of Wednesday's slides. The next place to look is the additional practice worksheets. These are available on Moodle. You can see the link to the folder highlighted here in this little picture. And there's 1 for Unit 1 and 2 for Unit 2 so far. These are from a commercial bank, so they don't have quite the same feel. They don't quite word things the same way that I would do. But in order that there's enough problems on every topics that people can engage with them, that's what I had to do. I had to go to a bank. So that's why they're maybe have a slightly different wording. These have answers at the end of the worksheet, but not solutions. They don't have full worked out solutions. And as I mentioned in class, I gave full solutions to these once and grades went down significantly. So I stopped doing that, right? But you do have the answer. So it'll tell you the answer is 6 or whatever it is. And then you have the practice exam there on Infinity. So this has the same structure, format, length, all that type of stuff as the real exam. And so it's good for getting a feel for that structure. Of course, the problems will be different on the real exam. It won't be the same problem with different numbers. It will be a riff, but it can at least give you a feel for the structure, okay? So one last thing about this practice exam is every year, every time people say the practice exam is easier than the real exam. No, this is not actually usually true. I often will use prior semester's exams as my practice exam, and there have been times where the practice exam score was lower than the real exam. Why does the real exam always feel harder? Stress. You're under stress in the real exam. It will always feel harder, even if it's not. I actually write the practice exam and the real exam side by side, and for each sort of problem type or topic, I choose the harder one to put in the real exam. So it should be a little harder, but it will probably feel easier because you're probably not doing it under the same conditions as the real exam, though you should. And you're not, even if you do it under the same conditions, you're not under the same stress. I mean, you can get it close by trying the practice exam under exam-like conditions. Find a corner in the library or whatever have you. It's got the timer built in. Just try and do it and see how well you do, okay? My suggestion would be to look at, but don't do, the practice exam first. Just look at it so you get a feel for the structure, you get a feel for how many questions on each of the units, right? All those types of questions you get answered, right? But I will emphasize again, the practice exam is probably not enough practice for most people. You're probably going to need some of these other resources. Now, how would I approach doing it? I would say do the next time problems first. Because again, you know where to look if you get stuck. It's in that day's slides. And you have full solutions available if you need them. Now, hopefully you've been doing these as we go along, like I discussed in class. But if not, they're still there. Then after that, I would move on to the additional practice worksheets. These are a little bit more out of context. I mean, they're still grouped by topic, right? You've got a macroscopic energy and a microscopic energy worksheet, but they're not directly connected to any particular day's slides. And also, you don't have full solutions. So there's a little bit more of a challenge there. And then finally, go to the practice exam towards the end of your studying, not the last day. I'd probably do it a couple days, day or two before. You've only got the one. And once you've used it, you've used it. That's it, right? You've only got the one set of problems. And I'm telling you right now, those problems are not on the exam. So redoing problems over and over again isn't actually that helpful. I know a lot of people like to do it, but it's not actually that helpful, because think about what you're doing when you do that. You're memorizing solutions to problems you've seen. And that's not what I'm going to test you on. I'm going to test you on your ability to do new problems. So there's a severe limit in redoing problems. It's not actually that helpful. Thus, once you've done the practice exam, that's it. You're done. You can't really get much more out of it. So like I said, I would do it a day or two before the exam, most likely, and then use that as sort of a test on my own studying, right? So you do the practice exam and say you get, I don't know, all the macroscopic energy questions correct. Awesome. But you missed some of the entropy stuff. Okay, now you know where to go back and focus a little bit more for the remaining study time you have, right? For the remaining time you've got, maybe don't focus too much on the macroscopic entropy, and instead go focus on the entropy, the stuff you missed on that practice exam. So you've got these different resources of different problems. What do you do if you can't figure a problem out? Well, first off, woohoo! That's what you want, right? If you can't figure a problem out, you have figured out something you don't know. You have learned what you don't know. And now you have a chance to fix it, fill in that gap, and learn, and hopefully, avoid that particular obstacle on the real exam. So getting problems wrong in your practice is fantastic if you do it intelligently and think about it, right? So first things first, when you get stuck, remember, you're solving a problem you haven't seen before. That's hard, and it takes time too. You need to give yourself the time to figure it out. This is a common mistake that folks make, is frankly, they give up too quick, right? It might take 5-8 minutes to figure a problem out. Make sure you give yourself enough time. There's a cool result from psychology research that says 10 to 15 minutes is about the right amount of time to really struggle with it. After that, if you're not making any headway, go get help. If you're making headway at that point, cool, keep going, right? But if you've banged your head against the wall for 10, 15 minutes, then it's time to go get help. But make sure you give yourself that 10 to 15 minutes to really struggle and grapple with the problem before moving on. So you've given yourself the time. What do you do next? You're stuck. You need some help. Instead of going and immediately asking somebody else for help, go back to a similar problem we did in class and see what we did. If it's a next time problem, well, that's easy to find, right? You look in that day's slides, not the answer, not the solution, the problems we did earlier that same day. If it's an additional practice problem, you try to find the equivalent topic. At the top of the in-class materials folders on Moodle, I've listed the topics for each day, roughly. And it's also in the file names. So find the similar topic, find a problem that's focused on the similar ideas. Of course, it won't be the same. It'll be a different one. But if you're struggling with, I don't know, applications of microscopic energy, then go find one of the problems we did on microscopic energy, right? And try to see if you can use that to figure out where you're stuck on this problem. Don't look at the details. Look at the process. Look at what we did. Is there some step in the process we did in class that you're missing in this problem you're trying to do right now? That's what you're looking for, okay? So try to figure it out on your own. The 10 to 15 minute clock kicks in here again. And if you can't, then go and get some help from somebody else. When you do finally figure it out, you're not done. You're not done. The next step is to try to articulate to yourself where you got stuck and how you got unstuck. Write it down. Don't just do it in your head, because it's very easy to sort of trick yourself of, oh yeah, I got this. I know I'm super guilty of that. But if I try to write it down, I will find exactly where I don't know something, because I'll be forced to articulate it out, writing it out. And I'll be like, wait, I can't explain this. Go back, figure it out. Yes, this is slow, but this is what it takes to do, right? Another thing, though, is if you look in your metacognitive journal, one of the options is this problem-solving journal idea. So look at those instructions and basically do one of those for the problems you missed in your studying. So try to follow that process. And you can upload problems from your studying to your metacognitive journal. Those count. So this is a way you can really get, sort of two birds for one stone, so to speak. Right? So key emphasis again is, if you can't figure it out, that's fantastic. That's what you want, because that's how you figure out what you're missing and how you learn and how you improve. If you're getting the problems right, then go do something else, right? Go do a different topic. If you get 5 problems right in a row, you're done. Go do something else. So that's my suggestion there. So let's say you're looking at what we did in class, or even the solution, and you still can't figure it out. First off, don't feel bad. I have been in so many classes where I'm looking at the answer to a problem and I still don't know what's going on, right? It's not that unusual. That actually does happen. So what do you do in that case? Well, most likely, like I said, there's some concept you're missing. The key thing to avoid here is, I forgot so-and-so formula. It's never a formula you're missing. It's never an equation you're missing. There's a concept about how the world works, and maybe the translation of that concept into mathematics that's not clicking. That's the number one thing to keep in mind. It's a concept you're missing, not a mathematical thing, right? So go back to the relevant homework. Say you're struggling with the distinctions between temperature, heat, and thermal energy. Go back to the homework, because the homework, by design, removes the math from the mix, right? So it simplifies things and allows you to really focus on just the concept. And so you can focus on that, and maybe that helps. And if not, well, keep going backwards. Go to the book. And if that still doesn't work, well, we do have these other resources, right? The Discord and the help room and all of those types of things. So to sort of summarize up some do's and don'ts for studying, first, the do's. Do make sure you understand the concepts and how you go from the concepts to the equations. The equations follow from the concepts, not the other way around. Hopefully you're getting tired of hearing me say this, but that's really the thing. It's the concepts that we're doing. Physics isn't math, right? It's a set of rules that govern how the universe works that we're trying to understand. And then we express those rules mathematically. But the rules, the story, is the physics. Do focus on the types of problems we did in class. This is more representative of the level that we're going to have on your exam. The homework will not prepare you for the exam, right? We talked about this in class. The homework prepares you for class. Now, of course, if you're struggling with something from class, you can go back to the homework to try and brush up your background knowledge. But just keep in mind that the homework is not sufficient for the exam. And do make sure that you are comfortable with the spreadsheet tool, right? You're not going to get a calculator, because I really want y'all to learn how to use this spreadsheet thing. And as we mentioned in class, the only way to get super comfortable with something is to just use it. And so, yes, I am going to force you to use it. So for every problem, use a spreadsheet. If you're wondering, that's inconvenient when I'm working at a whiteboard, I don't want to hold my laptop or whatever, pull up a Google Sheet or something on your phone and you can do it there, and it worked fine for most of the calculations we're doing up to this point. You can just do it on a phone and it will be perfectly fine. Okay. Some common mistakes folks make is don't confuse the ability to read a solution with being able to do the problem. Remember the pullback tap step I started class with. I gave you a lecture, I asked for questions, I demonstrated it, and there were no questions, but doing it was a whole different beast, right? So with this in mind, solutions aren't something to just collect. You're not trying to collect solutions for all the problems and memorize them. No, you're not. It's not a collection thing. The solutions are there to help you figure out where you were stuck, right? So even on Discord, before asking for a straight solution or looking for it, there's been quite a bit of them answered at this point on Discord. Ask why, or how did I get started, or what am I missing, right? Those are better questions. And then if you need it, go get the solution. I mean, you're not forbidden, go for it. But keep this thing in mind. So many people confuse being able to read an answer with being able to do an answer. Those are related but different skills. A lot more people can read than can do. And I want you to be able to do, right? So make sure you're focusing on that. By the way, this is why I think when I provided solutions to the additional practice problems, grades went down, is because I was giving solutions. People were reading them and thought they understood the problem. And when reading and doing are different things. Don't give up on a problem. Don't skip it. If you're stuck, don't move on. I know it can be frustrating. I know it's hard. But the problem you don't get is the one that's trying to show you what you don't know. If you can't get a problem, it's showing that there's some concept or some mathematical representation of that concept that you don't fully understand. The problems you don't get are the ones where you get the real benefit from your studying, okay? And finally, don't just focus on the practice exam. I know I'm sounding like a broken record repeating myself, but don't just focus on it. This is another super common trap people fall into. It's probably not enough practice for most people. You're probably going to need some of these other resources, the next time problems, the additional practice, all that sort of stuff, okay? So some last things to keep in mind. I've mentioned that this is frustrating and hard, and it takes a lot of time. Yes, it does. Learning is fundamentally hard work. There's no way around that. It's like strength training, right? It is intrinsically difficult. It is intrinsically takes effort. It intrinsically takes work. And so, in particular, for a class like this, where it's a new way of thinking for a lot of y'all. Another example is if you went to take a course in something wildly outside of all of our disciplines, I don't know, history or philosophy, you'd probably have to put a lot more work into it because it would be a different and new way of thinking than what you're used to. And moreover, with this class in particular, you're learning a new language alongside it. And so that's a lot to learn. And that takes a lot of work. There's just no way around it. Second, follow our process. Don't skip steps. Don't make up your own, right? Don't panic. You're not going to know how to get from the beginning of a problem to the end by looking at it. Not going to happen, right? You've got to actually just solve it out and think. You're not going to know all the steps out of the gate. You're going to have to figure it out as you go. That's why it's called problem solving, right? So follow our process. Don't panic. Do the story in terms of the physics quantities, the entropy, the energy, not the surface stuff, not the blocks or the ramps or no. In terms of those deep physical ideas, the titles of our units, energy, entropy, those types of things. Then take that story, translate it into mathematics using our principles, so conservation of energy, that sort of stuff. Then input your definitions for all your quantities. do some algebra to simplify your life. This is the step where you care about what you're solving for, right? So isolate what you're solving for. Put in numbers. You know, if you've got numbers, great. If it's a less numbery problem, you can maybe still put in that VF is twice VI or something like that. You know, that's why I put numbers in sort of quotes here, is sometimes it's not, you know, 6 or 6.32. It's VF is twice VI, or HF is twice HI, or half or a third, or whatever, right? So put in those types of numbers. And then you've got to read your math. You have to interpret your result. Okay? So this is the process that always works. This is the process for every problem we've done this entire semester. Follow this. Don't go making up your own. Don't go starting with equations and trying to fit them together. No, no, no. Start with the story. That's where the physics is in the physics class. Okay? And then focus on what can be generalized from each problem we did. So what's the takeaway from that problem? Hint, it's in the weekly broadcasts that I've been sending out each week. There's a, by the end of this week, you should be able to, that's the thing, okay? So they're there, but once again, if you're scratching your head going, I don't remember that, awesome. That's proof that reading it doesn't stick, right? Reading doesn't stick in your head. You have to actually do it. If you write it yourself, it'll stick. If you're just reading mine, it's probably not going to stick. That's just not how the human brain works. There's a famous quote from ancient China, which is, I see and I forget. I hear and I forget. I see, I remember. I do, I understand. And understand is what we're going for. And that requires you to do. Okay? Hope y'all have found this helpful. And this concludes this video.